Hello, and welcome back to another sports statistics lesson, as best as we can do right now. So, first things first, nice job, everybody with a lab. I'll be sending out like individual feedback, but good job. Hopefully, kind of what most of you saw was that when you took one season of data, you ended up with a higher p-value. And then when you looked at 5 or 6 seasons of data, that p-value came down. Now, again, I know that wasn't true for everybody looking through your sheets, but for the most part it was. And I just want to talk about that quickly before we talk about sort of today's idea. So again, we expect to see differences. We expect to see a difference between your home winning percentage and your away winning percentage. Today, we're going to look at a lot of different things, and we expect to see differences between those. But the question always is how meaningful is that difference? Is it just random fluctuation, or is it the sign of something that truly matters? And the way that we can usually establish that is either there has to be a really big difference, like such a huge gap between two things that we're measuring that there's no way it's a fluke, or if there's a smaller gap, we need to see that gap sort of repeat year after year after year after year. And if it keeps repeating, we can be more sure that it's real, even if it's a small difference. And that was kind of the idea with the home field advantage. It's not like home field advantage is this giant advantage that suddenly turns a horrible team into a great team, but there are little small advantages that pile up. So if we see that over years and over decades and over however long, the home teams are always winning just a little bit more than the away teams, we can start to establish that there's a real difference between home and away, and it's not just some random fluctuation. And that brings us to the article that I linked today. It talks about icing the kicker, and then it shows you some differences between iced versus not iced. And again, this is the perspective that I want you to take, because when you watch sports, they're always going to give you like, oh, these are the numbers of the player at home, or these are the number of the players on the road, or this is the number of the players during a day game, or this is the numbers when it's cold out or when it's warm out. And what you always have to ask yourself is, are those differences significant? All right. So yes, there's a gap between iced and not iced, but is that gap large enough to be significant? Again, we have a gap here. It's only 0.3%. That's probably not large enough to really be significant. Now, if it shows up year after 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 year, then maybe it is, and it's just a really small advantage or disadvantage, as the case may be. But that's sort of the perspective that you want to start to develop when looking at stats. It's not just that they're different, it's how different, and is that difference meaningful? And again, what we're going to see again in today's examples are you either need a really big difference or you need a smaller difference that shows up time and time and time again so that you become more certain that it's real and it's legitimate. All right, so last week we looked at proportions. All right, this week we're going to look at means. And it's going to be a similar exercise to what we were doing last time. We're going to use a similar applet. We're just going to be dealing with means instead of proportions. So what I have here is I have the runs scored for National League teams that do not use a designated hitter, which means their pitcher has to bat. And I have runs for American League teams where there is a designated hitter. Now, I just randomly picked the year 1998. Don't ask me why I picked 1998. It was just the year that I picked. All right. So what we're going to do here is I'm going to take these numbers and I'm going to paste them into the applet. So the nice thing is when I highlight these from the spreadsheet and I copy them, it'll paste it over quite nicely right in here. So I just paste over. And then same thing if I go back and I highlight this and I paste them in. All right, and then I say calculate observed difference. That'll tell me that the National League teams, because those are the ones I pasted in first, average 733 runs. The American League teams, which I pasted in second, average 774 runs, which means there was a gap of 40 runs between National League and American League on average. When we averaged all the teams together, the gap was 40 runs. Again, the question that we're always asking is that gap meaningful? Is that large enough to be meaningful? So we're going to do the same sort of thing we did last time. I'm going to take 1,000 trials. I'm going to add them to my dot plot. All right, so there's my dot plot. I'm going to go down here and I'm going to count the percent of dots less than, and then what I type in that box is the number that I got there. So negative 40.759. Now, I did less than because I have a negative result here. All right. If my observed difference had been positive, I would have done greater than. All right. But because my observed difference was negative, I'm doing less than. All right. I'm going to count what percent this is. And then it's going to tell me that it was 4.9% of dots that are less than or equal to the specified value. Now, again, I said generally that our threshold is 5%. You want it to be less than 5%. So this is right on the edge there. It's technically a little less, but this gives us sort of evidence that, yes, a DH matters. All right. That gap that we saw is meaningful because it ended up just under 5%. Now, again, 4.9% is right on the edge there. So it might be that we'd want to get more data. All right. So if we're going to get more data, what you're going to usually want to do inside of this app here is you're going to hit reset. All right. That'll clear out the dot plot. And then you can also go in here and delete out all these numbers. Now, it's annoying to just have to delete them all out or highlight them. If you hit on your keyboard Control A, that highlights everything. And then you can just hit delete and that'll get rid of it. And then I can go down here again, hit Control A, hit delete, and that'll get rid of it. So what I'm going to do now is I'm going to go to the second tab, and this has 5 years worth of data. All right, so instead of just looking at a single year, I'm going to look at 5 years of data. So I'm going to copy this in. I'm going to go over here, put it into context 1. I'm going to go over here and do the same thing. I'm going to highlight all this data, paste it into context 2. I'm going to calculate the observed difference. And what you'll notice here is that when I use more data, the difference actually shrunk. All right, so the observed difference went from 40 runs from the first year that we looked at to just an average of negative 28. So still, the American League is scoring more, but the average actually got the average difference actually got smaller as I went. So again, I'm going to do 1,000 trials. I'm going to add more trials. And then this time I'm going to count the percent less than negative 28.14. So I've got to go down here. I've got to change that to negative 28.145. I'm going to count those. And it only ends up being 1.9%. So again, that's just more evidence that, yes, the DH is a significant factor. Now, the part that's maybe not intuitive here is that the gap got smaller, but my p-value went down. You would think if there was a smaller gap that the p-value would go up because we'd be less certain. But the reason the p-value is actually going down is because we have so much more data. So it wasn't just 1 year where the American League was scoring more than the National League. It was 5 years. So we saw the same thing year after year after year after year. And that sort of gives us more confidence that it wasn't just some random fluke, that in fact the American League is scoring more than the National League on average. And that's what this number is representing, is that based on the data we collected, the odds of seeing this gap are really, really tiny, all right, if there's no difference between the two leagues. So because this is so small, our conclusion is that there is, in fact, a difference. All right. So again, this general idea of we observe something in sports, we see there's a difference, whether it's home, away, DH, no DH, warm, cold, early season, late season, and then we're trying to figure out, is that difference real? Does it mean something? Is there a legitimate difference between the teams, the players, whatever? Or is it just sort of random fluctuation? And this is kind of how we can separate random fluctuation from a meaningful difference. When this gets below 5%, we say that it's meaningful. When it ends up above 5%, we say that it's not meaningful, or it's, probably random. It could be random fluctuation. Doesn't mean it's random fluctuation, but we don't have enough evidence to say that it's not. All right. So last thing I want to talk about is just some vocabulary that goes along with this. So I'm going to do one more example here. So again, I'm going to reset this. That clears away the dots. I'm going to go up here. I'm going to do Control A and delete it out. Then I'm going to do Control A and delete it out. All right. So what we're actually doing here in statistics is something called hypothesis testing. All right. So hypothesis testing is a fundamental part of what's called inferential statistics, and it basically just lets us test different things. Now, there are two terms that go along with hypothesis testing. There's what's called your null hypothesis, and there's what's called your alternative hypothesis. And the way these work is your null hypothesis is always that there's no difference between the two things that you're studying. And your alternative hypothesis is that there is a difference. So if we go back to the DH one that we just did, the null hypothesis would be that there is no difference between how many runs a team scores with designated hitters versus how many runs a team scores with no designated hitters. Your alternative hypothesis would be that a designated hitter helps you score more. Right? So again, null is that there's no difference. Designated hitter, no designated hitter, doesn't make a difference. The alternative is always whatever you're actually looking for. So in this case, the designated hitter helps score runs. So here's another example. This is NFL data, and it looks at passing yards per game. And it looks at 1977 and 1978. And the reason that we use those 2 years is because there was a rule change after the 1977 season that affected basically how receivers could be guarded and basically opened up the passing game in the NFL. So what we're going to study is whether or not that rule actually made a difference. So we're going to look at the passing yards per game before the rule. We're going to look at the passing yards per game after the rule, and then try to see whether it made a difference. So again, using the language, our null hypothesis would be that there's no difference in passing yards per game from 1977 to 1978. Our alternative hypothesis would be that passing yards increased from 1977 to 1978. All right. So there's some extra vocabulary, but the process is exactly the same. So I would take these right here. I would copy and paste them into context one. I would go over here. I'd highlight these, copy and paste them into context two, calculate the observed difference. Negative 15.238. All right. So again, we can see that the average passing yards in 77 was 141, The average passing yards in 78 was 157, so it did go up. It went up by about 15. The question is that a meaningful difference? So we go in here, we simulate 1,000 trials. Right, we're going to count how many are less than negative 15.238. And we see that it's only 2.4% of dots. So that's a meaningful difference. So what we usually say in statistics is we say we reject the null that 1977 and 1978 are the same, and we accept the alternative, which is that passing increased in 1978. So again, that's just some language that gets used in like more formal statistics. We reject the null that they're the same and accept the alternative. If this had been over 5%, the language we generally use is that we fail to reject the null. We fail to reject the claim that the two seasons are different. Or not different. I'm sorry, that the two seasons are not different. All right. So anyways, this is the sort of thing you're going to be doing in your lab. You'll see that, the questions are, state the null and alternative hypothesis. So again, null is that there's no difference. Alternative is that there is a difference. And then which one you think, which direction that difference is in. It's going to ask you to calculate some averages. It's going to ask you to speculate on whether you think that difference is significant. And then you're actually going to run the p-value tests. Now, the differences that you're going to be doing are, there's two other tabs in here. One is quarterback ratings for Peyton Manning. All right, so if you don't know who he is, one of the greatest quarterbacks in NFL history. But one of the slights against him, it was claimed that he was only really good in domes. Like, he had to be in a dome stadium, and if he was out playing in the elements, he wasn't nearly as good. So you're going to be looking at his quarterback ratings from games that were played outside, and then you're going to be looking at his quarterback ratings for games that were played inside, and you're going to see, is there a meaningful difference between his average outside and his average inside? Because they are going to be different, but the question is that difference going to be meaningful? And then the other one that you're going to look at is baseball home run totals. And the reason you're using 2006 and 2008 is in 2007 was when the Mitchell report was released, which was like a major investigation into steroid use in baseball. So you're going to look at home run totals in 2006 before the Mitchell report was released. And then you're going to look at home run totals in 2008 after the Mitchell report was released and see, is there a significant difference in those totals? Did home runs go down in 2008 after baseball cracked down on steroids, or did the Mitchell report not really make much of a difference? So again, that's what you're going to be looking at. You're going to be calculating the averages. You're going to be looking at the differences. You're going to see whether those differences are significant. Because that's the big idea here is there's always going to be gaps, but do those gaps mean something? Are they actually important enough to take notice of, or are they just gaps that happen because there's always going to be random variation? All right. So again, best of luck. I hope things are going well, and email me if you have any questions. All right.